Okay, so in the last class, we spoke about the spread of data and we use quartiles and the medians. The problem is that this only takes like individual pieces of data. And the idea is we want something that brings together every single piece of data. So today we're going to talk about variance, standard deviation, among other things. So the example I generally give to introduce this topic is I introduce, imagine you're a coach on a basketball team and you learned today that one of your players broke their leg and you need to audition two new players. And you've decided that you're going to use the number of baskets scored in the last couple of games, last four games, to determine, whether this is a player you want for your team. So the first player in the last, player one in the last couple of games got a 23, 25, 27, and 24. And player two got 31, 33, 30, and 32. And so you've decided that you're not just going to look at the median, you're not going to look at the maximum, you're going to look at the mean, which brings all the pieces of data together to reach your final statistic. So we're going to add, we will two, so let's see, 3, 8, 15, 19, so it's 99. You know what? I'm going to change this to 25 to make my life easier. So the total point scored is 100. I'm looking at 4 samples, therefore the mean is 25. And let's see what's going on with player 2. Well, let's see. I have all threes here, so I have 1, 3, 6. So I have 100. The sum is 126. I also have 4 samples, and what is that? That's 3. Let's see, 3.15, 31.5. Okay, and so you say, Coach, we're going to go with the second player because they have a mean of 31.5, and you say, great. The next week, you discover that another player got sick. They have mono or something, and they're out for the season. So you say, okay, let's bring 2 more players, and we'll use the same method. The mean seemed like a good way, and the other team players were fine with that. So player 3 had a mean of 24, 26, 24, and 26, and player 4 had the scores of 25, 25, 25, and 25. And let's change. I'm sorry, so it was wrong actually. Let's change this. I'm sorry, these are not the scores. 21 and 27 and 29, 21 and 29. So you say, okay, let's find the mean for both of them. Fine. Let's see, this is 50, 50, so this is 100 divided by 4. This mean is 25. And then what's going on here, this is also, the sum is 100, and the mean is also 25. And so you say, well, they're the same player, but are they the same player? How does this data represent different players? And the question is, what can we use to represent this different? And that's where standard deviation and variance come in. What we're going to be studying with standard deviation and variance is the average distances from the mean. That's what we're interested in. Although once again, the deviation is like deviation from the mean. Now, first of all, the symbols we use for standard deviation and variance are like this. Standard deviation is simply sigma as a population. If we have a sample, which we're not talking about in this class, we'll use little s. Variation is just standard deviation squared. That's it. That's it. So once we find the standard deviation, we square it to get the variance. If someone gives you the variance, you take the square root. That's a standard deviation. Done. So how do we find these things? Well, let's choose 3 scores. Let's choose something simple. So how to find the standard deviation variance by hand. You're never, ever going to have to do this again. I'm showing you the behind the scenes. Step 1, write down the column, write down the data. So let's pick small numbers. How about 2, 3, 7, 11? 23. And how about we do 30? Good. Step 2, write down the mean. So what is the mean? Let's see. We have 5, 12, 23, 35. So the average is, so the sum is 35, therefore the average is 7. That's it. That's what the computer is doing with like millions of pieces of information. Step 2, subtract. So 2 minus 7, negative 5. 3 minus 7, negative 4. 7 minus 7, 0. 11 minus 7, 4. 12 minus 7, 5. Now, I'm just interested in the distances. I don't care about the directed distances. So how am I going to get rid of the negative? Square it. So what's negative 5 squared? 25. Negative 4 squared, 16, 0, 16, 25. Finally, find the average. What's the average? So find the average. And so let's see. So you're going to find the average of the distances from the center squared. So let's see. 50 plus 32 is 82. And so we have the sum is 82. 82 divided by 5. Hey Siri, 82 divided by 5.
82 divided by 5 is 16.4.
And this is the variance. Hey Siri. Hey Siri. Hey Siri. Square root of 16.4.
The square root of 16.4 is 4.04969.
And therefore the standard deviation is 4.1. On average, the scores are 4.1 units away from the center. And so this tells us something different. So for example, this one, player 3, has a higher standard deviation / variance than player 4. We can see that player 4 has a standard deviation of 0. And player 3 has a standard deviation of, whatever the distances are. But you can figure that out. It's 4s. The distances are 4s, 16, 4. The question, and I asked the students, which player do you want? Do you want a player with a greater standard deviation or a lower standard deviation? And obviously, that's subjective. Now, this is how we find the standard deviation / variance. This is doing it by hand. I'm never, ever making you do this by hand. What you are going to do is, in a paper, you might have to put the data in the calculator, which I'll show later, but then IB's not going to make you plug numbers into the calculator. They actually will. They might. We'll talk about it in a second. So this is the handout. I want to talk about a couple of things, though. So get this down. I'm erasing. Well, I'm not going to erase. I'm going to do it to the side. Let's see. I want to know what happens. What happens to the variance and the standard deviation and the mean? So what happens to the mean, standard deviation, and variance when the data is transformed? That's what I'm interested in. Once again, this is all I can. So let's get some rules. Let's see what happens. So let's take A plus B. Let's take 4 pieces of data. So we have a data set, and it is A, B, C, and D. So I make my first column. So the question is, what happens when I multiply each data by G? So that's 1. So let's think about this. So x1 is A, B, C, D. What's GXI? Well, it's GA, GB, GC, and GD. So what's the mean here? If the mean here is A plus B plus C plus D over 4, what's the mean of this new of GX? The mean of G. Let's see. This is GA plus GB plus GC plus GD over 4, which is equal to G times A plus B plus C plus D over 4. Final answer, this is equal to G average. So when we multiply every piece of data by G, we multiply the mean by G. Let's go on. Let's continue. Let's continue. What happens when I add H to all the data points? What happens to the mean? My computer is off. I hate that. What happens to, let's see. So we have xi plus h. So we have a plus h, b plus h, c plus h, d plus h. So we have a plus b plus c plus d plus 4h divided by 4. We have the mean plus h. So when we add h, a constant, to all the data values, the mean gets added by h. Next, what happens to the standard deviation and the mean? The standard deviation and the variance. Well, let's put it in a table. Let's see what's going on. Actually, the lesson I want to do GHI plus h. Well, you can kind of guess what happens if the mean is the mean, then you can probably guess correctly that is the new mean of the transformed data, of the transformed data. So once again, in your science class, your economics class, if you take every single piece of data, multiply it by G, and add H, the new mean is the old mean times G plus H. Next, what happens with the standard deviation / variance? Well, let's see. So we want to look at GX. We want to look at what happens to the standard deviation and variance when we multiply all the data by, it's like a vertical stretch, right? Yeah, no, it's a horizontal stretch because we're pulling our data out, right? So let's see. We have GA, GB, GC, GD. Okay, that's the data. We have the new mean, which is G all the way down. Let's see, GA minus GB minus G mean, GC minus G mean, GD minus G mean, right? What was the next step? Square everything. GA minus G mean squared, GB minus G mean squared, GC minus G mean squared, GD minus G mean squared. Okay, what are we going to do? We're going to add all these up. So what's going on here? So we have, let's see. Well, we're good mathematicians, so we're going to add these up and find the average. Well, actually, we can factor out the g squared. So we have a minus squared plus g squared times b minus. Now you can see where I'm going with this. You don't have to copy this down. You know what's going on. All this is divided by 4, right? So the variance, so what's going on here? When we pull out the g, the variance of gx is equal to g squared times the variance of x. Once again, if you multiply all the data by g, we see here mathematically, you never have to do this again, but the idea is, once again, if you take all your data and transform it by multiplying by g, the variance, it's the original variance times the transformation, which we know is a horizontal stretch, that's squared. And therefore, what's the standard deviation of a data set that was multiplied by h? Well, that's just g, standard deviation of x. That's the idea. What's going on with if we shift everything? What do you think? I mean, what do you think happens to the variance? Have we stretched, if we shift something over, have we stretched it at all? And so the answer is nothing happens with a translation. Nothing happens with a translation. So we can clearly see that the variance of x plus h is equal to the variance of x. That spread does not change. It doesn't matter if I move it here. Once again, with our original example, the basketball scores, if I add 5 to the whole scores, that doesn't change the stretch. If I multiply the scores, that spreads it out. When you can mathematically see that, well, let's go over here. Inside of my GAs, we know that the column, it's A plus H and mean plus H. And therefore, when we take the difference, we're just back to this, the H's drop out, and then we're just finding the standard deviation. So the variance of data that has been translated is the same variance, and therefore the standard deviation of data that has been translated still has the same standard deviation. Good. Let's do some more stuff that you don't have to know. I just want to show you this stuff. What else I want to show you? The variance, nice. Okay, a couple of other things. Let's just some sigma notation. We know, just quick review of sigma notation. The idea is you start from, you start from I from 0 up to some n. And so if you have data point, this is the first plus the second plus the third, all the way up to whatever the n is. Let's start at 1. So we start at 1, 2. This is the idea of sigma notation. And we had a couple of things. So for example, if I multiply all the pieces of data by g, I could just pull that g out and then do the regular sigma notation. So if it's a constant, it's not changing, pull it out. And then the other thing, what else? Well, we know some notes, and we also know that, the sigma of AI plus BI is equal to the individual sigmas. You can break them up, sigmas. And then the last thing we saw is that we kind of put it together so we can use this notation. So the sigma of, from I to 1 up to n of, xi over n, this actually is the fancy way of writing mean, right? Because we're adding up all the data, we're adding up n pieces of data and dividing by n. So this is the mean, okay? And so therefore, I think I wrote it before, but using sigma notation, we know that the variance of x, when I write this letter x, I mean all the data. I'm saying that it's this, we added up the distances of the data from the mean squared over n. And so what I erase that. Good. So the variance was the summation of the differences of a data point to the mean squared divided by n. We found the average of those squared distances. Fine. The first thing we're going to do is expand the binomial. So we have xi squared minus 2xi, xi mean plus mean squared. Well, the third rule here, the second rule is that I can take sigma of each term. So let's write this out. We have the sigma of xi squared over n minus sigma of 2xi mean over n plus x squared over the sigma of x squared over n. Good. Let's take apart each of these. Well, this is simple. We're just taking the once again, this is n terms. So we're adding up n terms and divided by n. Therefore, we're taking the average of whatever it is that we've added up n times. Well, it turns out in this case, we took our original data points and squared everything. So what we have here is the average. What we have here is the average of the data squared. And so, for example, like take all the basketball scores, square them, and take their average. That's technically what we did. Good. What's going on over here? Well, as I said before, if I have a constant, I can pull it out because it's like I'm adding up n terms, and every single one of them is going to have the 2 mean. So I'm going to pull it out to make my life a little easier. So let's pull it out. What's left is we have the sum of n data points divided by n. Well, you know what? This is just the average. So let me rewrite this over again. Minus 2 times the average squared, because once again we have the average, and then we multiplied it again. What's going on over here? What's going on here? Well, simply put, we've taken a constant and squared it. Imagine that the mean was 2, right? Imagine the mean was 2. Well, the first instruction is to square it. So you have 4. And then simply put, add 4 n times. And then divide by that n. Well, that brings us right back to our original mean. That would bring us back to our 4. So in this case, it's simply the mean squared. Well, we have this weird thing. So we now have x squared, the mean of the x squared, minus the mean squared. And this is a really quick way of finding the variance. Or if you're asked to find the variance and you're given the mean and the means and the data, and so you'll see this in the calculator. You're going to see this in the calculator. They're going to show you, we'll see this in the GDC. You're going to see the mean, but you're also going to see the sum of, you're going to see something like this. And that is going to help you. What you're going to do is you're going to take this value, divide it by 4, divide it by whatever the n is, and that's this, and you're going to subtract it from the mean squared, and that's going to quickly give you the variance. And we will see this in some problems, and I believe we're done. So let me just do a quick example. Let's see, you're given some data, 1, 5, 7, 11. Find the variance, the standard deviation / variance. And so it's very straightforward. First, let's add up the terms. So we have 1 plus 5 plus 7 plus 11 is 24. And so therefore, the mean is 6. Next thing we want to do is find the sum of the data squared. Well, 1 plus, 1 plus 5 squared plus 7 squared plus 11 squared is 100. Let's see. 136, 196, and then therefore, oh yeah. Therefore, the variance of our data set is equal to 49 minus 6 squared, which is 13, and therefore the standard deviation is radical 13. Once again, take the average of the data squared, the average of the data points squared, that gives us our the average of the x squared. We're going to have a different notation. Subtract that from the mean squared, and that gives you your variance. You don't have to do the whole chart. We're good.